Hello everyone. Today I will try to do moment distribution method. Today I will try to do some examples on moment distribution method in structural analysis 2. So let us consider one example. This is a given example. Analyze continuous beam shown in figure by moment distribution method. Draw SFD at BMD. So this is a given example. So we need to draw SFD BMD and we need to analyze the given example by using we need to analyze this given example by using moment distribution method. Okay. That is our aim is to analyze this by using moment distribution method. Now let us consider this. This example. So our first aim is to, please remember, before going for the solutions, our first aim is to find out what is the fixed end moment of the given problems. So here, there are some standard cases for beams or fixed beams. The given fixed, what is the fixed end moment for those beams are given here. Okay, so here is given what are all the fixed end moment for the various some standard beams. Okay, here one in beam with the fixed beam with point load, what will be the fixed end moments? Okay, is given like with the beam with fixed beam with point load exactly at the center, then what will be the FEM's fixed end moment will be WL by 8 minus WL by 8, and this will be plus WL by 8. MF of BA will be plus WL by 8. Similarly, if unsymmetrical loading is there, what will be the fixed end moment? If unsymmetrical loading is there, fixed end moment will be WA B square by L square. Similarly, this will be W A square B by L squares. So similarly, this is for if the fixed beam with 2-point loads. Sorry, 2-point loads. This is for proper cantilevers. So similarly, there are different some standard beam cases are given. What will be the fixed end moment for the same? Okay, what will be the fixed end moment for the same? So here and here. So it's given here. What will be the fixed end moment? So here it is given here. Sorry. So here, here beam with UDL fixed end will be WL square by 12 minus WL square by 12, and this will be plus WL square by 12. Okay, so these are all the standards cases of fixed beams are given here. So beam with UDL, beam with UVL, all those things that is given here. Okay, now. So now this is fixed beams with UDL. So it is plus WL square by L, WL square by 12, and this minus WL square by 12 is given. Okay, and like this. Now by using these some standard cases, find out what will be the fixed end moment for the same. Okay, now let us find out one by one fixed end. Our first step is to in moment distribution method, our first step is to calculate what is the fixed end moment or fixed end moments. Okay, let us calculate fixed end moments. Okay, fixed end moment, first step. So now let us come take one by one. MF of AB equals to, it's a unsymmetrical point load. So what will be that? W minus WA B square by L square. Okay, this is MF of AB. Similarly, calculate what will be the MF of BA equals to plus WA square B by L square. Here what will be the W? W is minus 40, and A is what? 3 meters. And B is 2 meters. Okay, 2 meters, 2 square by L square. L square is 5 square. So write down the value. Similarly here, plus W is 40, L is A is 3, A is 3 square, sorry, 3 square into B is 2 divided by L square means 5 square. So L square means 5 square. So write down the value. Similarly, we need to write down the value. Similarly, let us write down for BC span. MF of BC that equals to MF of BC equals to what? Is subjected to UDL. Subjected to a UDL. So it is minus W L square by minus WL square by 12. So minus 10 L is 4 square divided by 12. Write down the value. Similarly, you can write MF of CB. MF of CB will be plus WL square by 12. So it is plus W is 10, L is 4 square divided by 12. Okay. Similarly, you can write MF of CB. What is MF of CB? This is also minus W L square by 12. So what is minus? Minus W is 10, L is 5 square divided by 12. So you can write down the value. Similarly, MF of CB will be plus WL square by 12. So plus WL square by 12. So this will be W is plus W is 10, L is 5 square divided by 12. So let us write down the what is the value of that one. Okay. Now we can write what will be the value of that one. So now we need to write down what will be the value of those things. Now please we need to calculate and we need to write down what will be the value of. So MF of BA, how much will get? MF of BA you will get, so this is what, minus 43 into 2 square by 5 squares. So minus 42 square by 5 squares. So this is given. So we will get, so here minus 40 into 3 into 2 square divided by 5 square. So you will get this one. You will get this one. So we will write in another this thing, another color, fine, another point color with the another color. You can select another colors and you can write out. This you will get how much? Minus, I will get this is minus 19.2 kilonewton meter you will get, and MF of B will be 20. Sorry, you will get plus 28.8 kilonewton meter, and MF of BC will get minus 13.33 kilonewton meters. Similarly, MF of CB will get plus 13.33 kilonewton meters. So here MF of CB, sorry, this is BA and this is, guys, please, this is CD, sorry, CD, and this is DC, CD and this is DC. MF of CD is minus WL square by 12. So this we will get minus 20.83. Similarly, MF of DC will be plus 20.83 kilonewton meters. So this is the value we will get. Okay, this is the value you will get. This is the value you will get. Okay. Now your next step is to, this is first step is find out the fixed end moment. Find out the fixed end moment. Now our next step is to, now so here our next step is to calculate distribution factor. Use the notations DF. We need to calculate what will be the distribution factors. So we need to calculate what will be the distribution factors. We need to calculate what will be the distribution factors for the given example. Okay, given beams. Okay, now let us consider. Let us see the beams. What are all the intermediate? So what are all the? So let us take this for reference. That beam. Let us take this reference for the beam to easy way of calculations. I will copy it here. So yeah, let us consider this like I kept here like beams. Beams. Now let us calculate. We need to identify the which one is the intermediate support. Let us say B and C are the intermediate supports. B and C are the intermediate supports, and A and D are the end supports. Okay. Now let us identify which one is the intermediate support. Let us identify intermediate supports. Let us identify intermediate support. Which one is the intermediate support here? B is the intermediate support and C is the intermediate support. Then what are all the respective members for the joints, intermediate joints? So the members, here I written the members. What are all the members? Here I have members like BA, BA and BC are the members. B and BC are the members. Similarly, what are all the for intermediate support C? What are all the members? Correct members? It is CB and it is CD. CD. Okay, these are all the members. Okay, this is how it's a very easy of write down the distribution factors and something like that. Okay, now let us now what is the stiffness, relative stiffness for BA now? The relative stiffness for BA, now we need to remember one point. So while doing this, if with respect to intermediate support, if the far end is fixed or continuous, the relative stiffness will be I by L. Please remember the relative stiffness will be I by L. So please, very important, the relative stiffness will be how much? It's I by L. It's I by L. The relative stiffness will be taken as I by L. So if another way, if with respect to the intermediate support, if the far end support is simply supported roller or hinge, then your relative stiffness will be 3/4 of I by L. So these things we need to remember, 3/4 of I by L. So 3/4 of I by L. So okay, this is how we need to calculate. Here I is how much? Here I kept I. What will be the L? L is, you can see here, 3 meter and 2 meters, so it is 5 meters. So what is I by L? I by L will be, what will be the I by L? I by L will be 1 divided by 5. So 1 divided by 5, it is 0.2. It is 1 divided by 5. It is 0.2 I. It is 0.2 I. Similarly, BC. Now you can see here. You can check out this. You can check out that with respect to intermediate support B. 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 B will be with respect to intermediate support B, for BC member relative stiffness will be, so we can see with respect to C will be the continuous support. C is the continuous support. So if C is continuous support, then relative stiffness will be I by L. I by L. I by L. So very important. You need to remember, guys, please. If far end is, if you want, I will write down. If far end is fixed with respect to intermediate support, if far end is fixed, or if far end is fixed or continuous, if far end is fixed or continuous, far end fixed or are fixed or continuous, fixed or continuous, then K will be taken as K will be what? I by L. I by L. So very important. K will be I by L. Similarly, if for and is simply supported or roller or hinge, then K equals to 3/4 of relative stiffness will be 3/4 of I by L. Okay guys, the relative stiffness will be 3/4 of I by L. I by L. Okay, K will be 3/4 of I by L. So we need to remember this. So what will be the relative stiffness for the various conditions, support boundary conditions or support conditions? Okay. Now, so based on this, we calculated this. Based on this, we can. Then now with respect to B, C is continuous. This is I by L. I by L means 1 by I by 4. I by 4. So it is 0.25 I. 0.25 I. Then come to giant C now. Come to giant C now. With respect to C, B is continuous. So what is B is continuous if I by L be I by L. So then relative stiffness will be I by L. So this is also I by L. I by L is this is I divided by 4. It is 0.25 I. Then with respect to CD, with respect to C, D is simply supported. Then this will relative stiffness will be 3/4 of I by L. So 3/4 of what is I by L? I by L is 5. L is 5. So L is 5. So this is how much? L is 5. So 3/4 of I by L. 3/4 of I by L. So this will be 0.15 I. This will be 0.15 I. Okay guys, so this is how we need to do it. Now let us say next step is, next column is given as summation of K. Summation of K means we need to add at the intermediate giant summation of all intermediate supports. Summation of all intermediate supports will be 0.2 I, 0.2 I plus 0.25 I. This will be at the point B, this will be 0.45 I, 0.45 I, 0.45 I. Then this will be, what is that? 0.25 I plus 0.15 I. Then this will be 0.4 I, 0.4 I, 0.4 I, 0.4 I. Okay, 0.4 I. Then now we calculate what will be the distribution factors. So now the summation of K by summation of K. For this giant B, what will be the distribution factors? K by summation of K. So K by summation of K. So K by summation of K. So this will be what? 0.2 sorry. So we'll write once again this. Sorry. This will be 0.2 I divided by 0.45 I. Then you will get this will be 0.44. Okay, 0.44. Then next will be 0.25 I divided by 0.45 I. This will be 0.56. 0.56. 0.56. Similarly, here this will be how much? This will be, so this will be 0.25 I divided by 0.4 I we will get 0.625. Okay, 0.625 we will get, and similarly we will get this is what 0.15 I divided by 0.4 I will get 0.375 I. So these are the relative stiffness for the respective members. Okay, now please remember, guys, please remember this. So we need to remember that we need to remember the intermediate joint, the summation of the summation of distribution factors should be 1. So means BA is 0.44 and BC is 0.56. So if you add those two, you have to get 1. So this is a cross check. You can check. This is not I. This is 0.375. So we need to cross check these guys, please. Let us make sure that the distribution summation of distribution factor at each joint is 1. Each joint is 1. So we need to take care this. Okay, we need to take care this. Now next step is moment distribution table. So this is called moment distribution table. Third step is what? Moment distribution table. Moment distribution table. Now first step is to we need to write it on the what is the joints. What are the joints? Okay. Then let us write down the members. What are all the members? Okay, members. Let us note it down. What are all the members? Okay. So what are all the members? So here it is member and distribution factor and FEM. 1, 2, 3, 4. 1, 2, 3, 4. So here you can add. Here you can add another column here. Here you can add another columns. Insert row below. Yeah, I added another this thing. So yeah, or you can take this on the first side. So yeah. And here I can write. So moment distribution table. Okay. So moment distribution table. Slot row below. Now it is okay. Moment distribution table. Okay, this is moment distribution table. So now let us this is the joints. Now what you have to do, now let us consider the members. Now let us consider the members. What are all the members here? This is AB, this is BA, BC here, and CB here, CD, and this will be the DC. Okay. Next write distribution factors for the respective distribution factors. Here BA you got distribution factor is how much? 0.44. And here what is the distribution factor? It is 0.56. And what is the distribution factor? It will be 0.625, 0.625, 0.625, and this is 0.375, 0.375. Okay, these are distribution factors. Then FEMs. Let us write down the FEMs. What are the FEMs? So what are the FEMs here? FEM is minus 19.2. What you got there? 19.2, 28.8, and minus 13.33. This is plus 13.33, and this will be minus 20.83, minus 20.83, and plus 20.83. Okay, these are FEMs. Now what we have to do? Now you can see the real beam here. Real beam you can see. So you know that the last support D is, what is that? Last support D is, it is a simply supported. Then what will be there if the last support is simply supported? Then movement at this point MDC will be 0. So MDC will be 0, means I need to balance that movement. I need to balance that movement, or I need to release that movement. I have some FEM movements here. So to make it 0, I need to release that movement. Release that movement means I need to make it 0. How I have to make it 0 this? So I need to release this, means so make it minus. If I make this is release, I can say, you can release the word release and carry over. I have to do it. Then you release the movement. How much I have to release? Release minus 28 at the DC. Release minus 20 point, minus 20.83. I am releasing and carry over the half of the movement to the adjacent support. Very important, please. Carry over half of the movement to the adjacent support. So we need to release any simply supported hinge or roller is there. I need to make movement at the summation of movement at that point. Means I need make it 0 at the moment. I need to make it 0. Bending moment at that point will be 0 because it is hinge. Then what I have to do? Release the movement. What is the fixed movement is there? Minus 20.83. So that movement I need to release. Release means it is plus 20.83, means I need to make it minus 20.83 and carry half of the movement to the adjacent support. So how much it is? Minus 20.83 means it will be minus 10.41 will be carried to the next one. Minus 10.41 will be carried to the next one. Okay, that is next one. This is the case. Okay, now this is the case. Now next what I have to do? Next, let us say what are the, now let us write down the initial movement. Let us write down the initial movements. What is the initial movements now? Let us write down initial movements. So let us write down the initial movements. Now let us write down the initial movements. Then what is the initial movement now? Minus 19.2. So once again, better we add another row here, so to avoid the confusions. We'll add another row here to avoid the confusions. Yeah, so we'll add another row to avoid confusions. We'll add another row here. Okay. Yeah, initial movement will be minus 19.2. Minus 19.2. Initial movement will be minus 19.2, and here minus 19.2, and this will be 28.8, 28.8, and this will be minus 13.33 and plus 13.33, and this will be now minus 20.83 minus 10.41. This is minus 31.24, minus 31.24, and now I made it 0 because that is simply supported. I made it 0 because that is simply supported. Now your next step is to calculate. Next step is to we need to do the balance. Let us do the balance. Now I need to do the balance at the intermediate support. So which is the intermediate support? B and C are the intermediate support. So I need to do the balance. Movement at the balance, I need to do it. This is trial and error method. So what I have to do here, balance means, so add the movement at the giant B, intermediate means B and BC should be added. B and BC should be added. Add any movement at that point. B and BC. So this thing, if you see, yeah. So BABC should be added. Then what I have to do? Add summation of, take summation of movement at the intermediate support, multiply with the respective distribution factors, change the sign, write down the values. Okay, now let us add this one. What is that? 28.8. So let us add those two values. What is that? 28.8 minus, I need to do it, minus 13.33, minus 13.33. So how much you will get? You will get 15.47, 15.47. That should be multiplied with the what? Distribution factor, respective distribution factors. 15.47 into 0.44, 50.48 into 0.44. Change the sign, write down the values. Means 15.47 into 0.44, you will get 6.8. You will get 6.8. Change the sign, write down the values. This is the main important steps we need to follow, guys, please. Okay, main important steps you need to follow. Add summation of these two at the intermediate support. Do the summation of these two movements. Multiply with the distribution factor. Change the sign. Write down the values. Similarly, here you need to do it. So it is here how much you will get? Minus, that is 15.47 into 0.56. You will get minus 0.866. Okay. Similarly, here we need to do it. What is that here? Here what I need to do? So plus 13.33 minus 31.24. So here what I need to do? Plus 13.33 minus 31.24, we need to do it. It's a minus 17.91. Minus 17.91 multiply with the 0.625. Change the sign, write down the values. Means what is that? Minus 17.91 multiply with the 0.625. How much will you get? 11.19. Change the sign. Minus 11.19 you will get. Change the sign, write down the values. What is that? It will be 11.19. Similarly, what is that? Minus 17.91. Summation of these two movements. Minus 17.91. Multiply with the distribution factors. 0.375. Change the sign, write down the values. So I change the sign and I write down the values. How much it is? 6.72. 6.72. So very important steps, guys, please. Next step is we need to do the carry over. We need to do the carry over to the adjacent supports. So please remember where I need to do the carry over. Please remember If far end is fixed, if the far end is fixed or continuous, I need to do the carry over. Please remember this means I need to carry the 50% movement to the adjacent support with the same sign. Adjacent support with the same sign means. So let us say with respect to B now, we can check here. With respect to B, A is fixed. A is fixed. With respect to B, A is fixed means I can carry over the half of the movement. Half of the means 0.5 times the movement to the support A. Similarly, with respect to C, what is that? With respect to C, B is with respect to B, C is continuous. Then I have to carry over half of the 0.5% of movements, 0.5% movement to the adjacent supports. Similarly, C to B, 0.5 I need to do, but C to D I cannot do it because it is simply supported or hinge. Movement that point will be 0. So this point we need to remember, guys. Please, this point should be noted. Okay, we need to remember this point. So you need to remember these points. Now let us do this one. What is that? Balance. I need to do the balance. Next step is carry over. I need to carry the half of the movement to the adjacent support. So minus 6.8. Then half will be what? With the you need to carry with the same side. Minus 3.4. Minus 3.4. Here I can do the carry over. Here to here. C to B to C I can do it. C to B I can do it. Why? Because with respect to C, B is continuous. With respect to B, C is continuous. So I can do that. So you will get minus 5.59, minus 5.59, and this you will get minus 4.33. Here to here I cannot do because it is simply support. Zero movement should be carried on that side. Okay. Now, next, do the balance. Once again, I need to do the balance. Okay. Once again, I need to do the balance. So balance. So here, once again, I need to do the balance. What is the summation of movement at joint? B, intermediate support. It is minus 5.59. Minus 5.59. So this is summation of the movement at that point. So then what I have to do? As I said earlier, summation of the movement multiply with the distribution factors, change the sign, write down the values. Minus 5.59 multiply with the 0.44, minus 0.55 minus 5.59 multiply with the 0.44, change the sign, write down the values. Means we will get minus. So we'll get so guys, please, this is plus, not minus. Once again, why it is minus? It is plus. So 5.59 multiply with the 0.44, you will get 2.56. Change the sign, write down the values. Means minus 2.56. Similarly, this one minus 3.14. So minus 4.33 multiply with the distribution factor, change the sign, write down the values. So this is 2.78. Minus 4.33 multiply with the distribution factor, change the sign, write down the values. 1.62. This is 1.62. Now, what you have to do? Next step, carry over. Next step, I need to do the carry over. Means I need to carry half of the movement to the adjacent supports. I need to carry the half of movement to the adjacent supports. So here also, I can carry from B to C, C to B, carry over I can do it. Here to here I cannot carry. This is 0. Okay. Then minus 2.56, half of how much percent? 0.5 times the minus 2.56 I need to carry. So it is minus 1.28. Minus 1.28. and this will be 1.39 will get, and this will get minus 1.57 you will get. Okay, this is carryover. Next we can do another trials. Let us do another trials. So this is balance. Now once again I need to do the balance. Once again I need to do the balance. Balance means here we got 1.39. 1.39 is there. So summation of the moment of the intermediate support. Then multiply with the distribution factor. Multiply with the distribution factor. Change the sign. Write down the values. You do it. 1.39 into 0.44. You will get, how much you will get? Minus 0.616. Similarly, here you will get minus 0.765 will get. Here minus 1.57, minus 1.57. Here it is what? Minus 1.57 it is there. Minus 1.57 is there. Now what I have to do? Multiply with the distribution factor. Change the sign. Write down the values. Means it is plus 0.98 you will get. 0.98. And similarly here you will get plus 0.59 you will get. Okay. Now what I have to do? Next I need to do the carry over. Carry over. Next I need to do the carry over. Means half of the movement to the joint A, because that is fixed. Half of the movement to the from B to C, because that is continuous. C to B, because that is B is continuous with respect to C. Then here no movement should be carried. Then you will get here. Then you will get here minus 0.31, minus 0.31, 0.49, minus 0.383, minus 0.383 will get, then moment of this minute is 0. Then do once again do the balance. Let once again do the balance. Now if you do once again do the balance, it will be what? 0.49 multiply with the 0.44, change the sign, write down the values. It will be minus 0.23, and this will be minus 0.27, and this will be plus 0.24, and this will be plus 0.144. Now I need to do the carryover. So change the sign. Now you have to maintain the same sign. Sorry, not change the sign. That's only doing the balance, and this will be so here. So 0.23 divided by into so this is 0.115 minus 0.115 minus 0.115. This is 0.115. So minus 0.115. Okay, and this is 0.14. 0.12 is there. 0.24 12, and this will be 0.27 into 5. You will get 0.135. You will get 0.135. So this is plus you will get here. How much you will get here? Plus We'll get plus 0.135. Here to here 0 is please. Here to here 0. Okay. Here to here is 0. So now we can balance this. Once again, you can balance this. Balance. So balance. So if you do the balance, it will be if you do the balance, it will be point, how much it is? Point, we'll cross check with this 0.49 multiply with the 0.44, 0.21, 0.49, 0.49 multiply with the 0.44 is 0.1, 0.21, 300. Then this will be so 0.45 multiply with 0.56, 0.27. Okay. So this case we will get max approximately we will get, guys, please. Now we can do the balance. Now let us do the balance this one. So if you do the balance, it will be 0.12, 0.12, 0.12, 0.12, 0.44. So we'll get 0.0. We'll get point. Here point. Change the sign, write in the values. 0.0528. 0.0528 you will get. So similarly at these portions, you will get how much you will get? 0.56 is point minus 0.0672 will get. Similarly 0.135, it is 0.135 is there. So here 0.135 into multiply with the 0.625, 0.084, 0.084. So similarly 0.050. Okay. So now I can end here. So we can you can end your iterations at these positions. You can end your iterations at these positions. You can end your iterations, and you can end your iterations. You can stop your iteration at these positions, and approximately you can write down the final movements how much you will get. Final movements. Okay. Final movements. Approximately will get. You can cross check with the values. Approximately will get. This is minus. Roughly I'm writing as please minus 24 or 24.34, 24.34. This is 18.54, 18.54. This is minus 18.61 approximately I'm writing, and this is 22.15 minus 22.15, and this is 0. So nearby value will get. You can add all these values. So definitely will get nearby the values. Okay, nearby value. These are final movements. Final movements will get. Okay, these are the final movements you will get at this machine. Next, next what I have to do? Next, let us take the real beam. Let us take the real beam here. Let us take the real beam. Yeah, let us take the real beam. So this is a real beam. So let us take real beam, and so this is a real beam, and this is a real beam here. So it is a real beam. Okay. Then so let us take the real beam. Now what I have to do? Next step is to, now you already calculated the sum moments. So you got here MAB is what? Plus how much? 24.4 34 kilonewton meter you got 24.34, and this is also MBA is plus 18.34 plus 18.34 plus 18.34. This is minus 18.34, so it's a 18.34 kilonewton meters. Okay, so it is pulling up. Similarly, this is plus. Okay, so this is plus, this is minus you got, and this is plus you got, and this is minus you got. Okay, how much it is? This you got 22.15 kilonewton meters, and this is 0 you got. So let us say you need to find out now support reactions. Let us say this is RA, and this is RB, and this is RC, and this is RD now. Okay, RD now. Now what you have to do? Now you can separate this. You can separate and write down those beams, and you can find out what is the support moment. So now we can divide this separately. I can write down the beams. So like this, and this is AB portions, and similarly I can write down this is for BC, and similarly I can write down CD. Okay, this is AB1, this is BC, and this is CD. Here I have, here what I have the loads we have. See, here I have loads like 40 kilonewtons, 3 meter and 2 meters. I have UDL here of 10 kilonewton per meters. Similarly, UDL of 10 kilonewton per meters. This is 5 meter and this is 4 meter. Okay, this is RA, this is RB dash, this RB double dash, RC dash, this RC double dash, and this is RD. Now by taking, now let us take let us take one portions one by one at a time and try to find out what are the reactions. Now let us take sigma MB that equals to 0, and here I forgot to write what are the moments we got here. So what are the moments we got, and also you need to show here. So here what are the moments we got here? It is, I got 0 here. I got here 22.15. I got here 18 point, sorry, here I got 18.34 I got here, and here 18.34 I got 18.34, and here I got, how much you got here? Here I have 22.15 kilonewton meters. Okay, this is kilonewton meter, this is also kilonewton meter, and this is kilonewton meters. So here 24.34 kilonewton meters, and this is 18.34 kilonewton meters. Okay, now so I shown that. Now what is your next step? My next step is to, now let us consider next step. What is the next step? Let us take algebraic sum of, let us say equilibrium condition. Let us consider equilibrium sigma MB that equals to 0. Then what is the sigma M equals to 0? 24.34 into 5, rotating clockwise it is plus, rotating clockwise it is plus, so rotating clockwise it is plus, then minus 24. Sorry, guys. This sorry. So it's not 24. Sorry here. Here RA into 5. This RA into 5. Rotating clockwise plus minus 24.34 minus of 40 into 2 plus of 18.34. That equals to 0. Okay, plus of 18.34, that equals to 0. Then RA equals to 17.15 kilonewton you will get. RA equals to 17.15 kilonewton you will get. Then this is the case. Okay, now use sigma Fi that equals to 0, sigma Fi that equals to 0, RA acting upward, RB dash acting upward, minus 40 that equals to 0. Then substitute what is RA here. Let us find out RB dash. RB dash equals to 22.85 kilonewtons. 22.85 kilonewtons. Okay, guys. This is RB dash. Similarly, sigma. Now let us take this beam. Sigma MB that equals to 0, RC dash into 4, it is minus and plus 10 into 4 into 2, load into distance into load into distance into distance by 2, then minus 18.34 plus 22.15. This is MB 22.15 that equals to 0. Then RC dash you will get 20.9 kilonewtons. This is 20.9 kilonewtons. Similarly, if you take sigma Fi that equals to 0, RB double dash acting upward plus RC dash minus of 10 into 4 that equals to 0. Then find out what is RB double dash. RB double dash you will get 19.1. Okay guys, 19.1 kilonewtons. So similarly, now here you can take RHS side and you can calculate. Okay. Now let us take sigma MD that equals to 0, sigma MD that equals to 0, RC double dash into 5, RC double dash into 5 is rotating clockwise plus minus 10 into load into distance by 2 UDL. This is for UDL. Then next minus 22.15 that equals to 0. Then you calculate RC double dash. RC double dash will get 29.5 kilonewtons. 29.5 kilonewtons you will get. Then use sigma Fi that equals to 0. Then let us calculate RD. Okay, let us take RD as, so sigma Fi equals to, what is that? This will be RD that equals to, uh, 10 into 5 minus of 29.5. 29.5. RD equals to 20.5 kilonewtons. So this is RD. Okay, this is RD. This is how we need to calculate the support reactions. Now let us take how to draw SFD. For the given this thing. Okay. Now what I have to do? Let us take how to draw SFD. For the given V. So I will show you how to draw your SFD for the given V. Just take copy and you can paste it here. So just I will show you how to calculate, how to show your how to show SFD and BMD. Okay, how to show SFD and BMD. So now let us show SFD and BMD for the respective sections. Let's do SFD BMD. So this thing. So better not to add this. So it's sure here. Yeah. Now you already calculated. So here I got RA equals to calculated 17.15 kilonewtons. Similarly, RB will be RB dash plus RB double dash. So we got this 41.95 kilonewtons. This RC we calculated VC1 VC dash plus VC double dash. So you got 50.40, and this you got 20.5. RD you got 20.5 kilonewtons. Okay. Now let us show SFD BMD for the given B. Okay. Now let us show SFD BMD for the given problem. Let us show SFD BMD for the given problem. Okay. Let us show SFD BMD for. Let us take this with the this is the datum line. Let us consider this is datum line. A datum line means R0 line. You can consider take it as. So from that datum line, whatever you draw from that datum line, so upward is positive, upward is taken as positive, downward is taken as negative. Okay. Here, what is that? Now start with the 0 here from point A. 17.551, it will come somewhere here. So this is, what is that? Point low, and this is point low. Okay, sorry. Point low. Okay. Now here it is what? 17.15, 17.15. Here to here is 17.15. Here to here there is no load region. Your SFD varies horizontally. And at this point 40, this is 17.15 kilonewton. At this point 40 kilonewton. So please remember, while drawing SFD, upward is positive, downward is negative when you are coming from left to right. So this is 40 kilonewton is acting downward, means plus 17.15 minus 40, it is 22.85. Let us say it will come somewhere here. 22.85, it will come somewhere here. Okay. 22. Here to here there is no load region. This is 22.85 kilonewton. Then here to here 22 here. Then 22.8 here minus 22.8 here plus 41.95 here. So it is 19.1. So 19.8 will come somewhere here. Okay, 19.1. Then plus 19.1 plus 19.1 minus 10 into 4, it's a 40, so it is 20.9. So 20 means it is comes somewhere 20.9. So it is 20.9 kilonewtons. So now minus 20.9 plus 50.40, 29.5. 29, so it is comes somewhere here. So it is 29.5 kilonewtons plus 29.5 minus 10 into 5, 50. So this is 20 point. This is around 20. It's also 20. 20.5 minus 20.5 plus 20.5, 0, 0, like this. So I started with the 0, I have to end with the zeros. This is plus, this is minus, this is plus, and this is minus, plus, and this is minus. Okay, this is how we need to draw shear force diagram. Now this is how we need to draw shear force. Now let us consider how to draw the BMD. Now let us draw the BMD. So let us draw on dotted line. Okay, here it is subjected to a point load, 40 kilonewtons, unsymmetrical loading is there. So what is the variation? Variation is, first please remember, while drawing SFD, BMD, we need to remember first, let us draw with the due to loading. Due to loading, what is the bending moment diagram? So what is bending moment diagram? So this is due to loading is subjected to a point load. This is like this. That is like this. Okay, this will be what? WAB by L. So WAB by L, you will get 48 kilonewton meters. This is due to loading. Okay. Now this is UDL. So it is UDL. So this is 20. So UDL, the variation is parabolic variations. The variation is parabolic variations. Similarly, this is the variation is a little bit higher variations. So this is parabolic. This should be parabolic. Guys, I'm drawing. Okay. So this is the maximum bending moment. This is also maximum bending moment. This is WL square by 8, 48 kilonewton meter. This will be WL square by 8. You will get WL square by 8. You will get 20 kilonewton meters. 20 kilonewton meter. Similarly, this is WL square by 8. You will get 31.25. So you will get 31.25 kilonewton meter. You will get. So this is the case. Okay. This is due to loading. Now I drawn the bending moment diagram due to the loading. Due to loading we draw. Now let us draw due to the support movements. So you already calculate what are the support movements we have. So at the support movements you already know what is the support movements, 24.34. So you show please 24.34 here. So let us say this is datum 24.34. And at this 18.54, it is lesser than that. Then at this 22 means it is somewhere here. And at this 0. Then let us join those lines. Sorry. Let us join those lines. Okay. So this is minus, this is plus, and this is plus, and this is plus, and this will be minus. You can write the values 24.34 kilonewton meters. This is 18.54 kilonewton meters, and this is 22.9 0.15 kilonewton meters. This is how we need to draw the BMD, guys. Please, this is how we need to draw the BMD. So clearly I have shown it here. So what are all the values and everything? So this is kilonewton meters. This is actual diagrams. So how we'll get? So kilonewton meters. This is kilonewton meters. 18.54 kilonewton meters. This is kilonewton meters. Okay, and everything here kilonewtons. Whatever all CFOs are in kilonewtons. Okay, this is movements are in kilonewton meters. Okay, this is BMD and SFD. So this is how we need to represent your BMD, bending moment diagram. This is how we need to represent your BMD, bending moment diagram. Okay guys, I hope you understood this example. Now let us consider another example. Yeah, let us consider another example. So consider this example. Let's consider another example. What is that? Analyze the continuous beam shown in figure by moment distribution method. Draw SFD and BMD. So this is another one. Both sides are with the fixed supports. Both sides with the fixed supports. As I said earlier, your first step is to, as soon as you see the problem, please the problem. Your first step is to draw. First step is to find out the fixed random moment. First is to find out what is the fixed random moment for the given beam. So now we can see here. So maybe I given what are the fixed random moments in the last problem while doing. I shown these are all some standard fixed random moments for cases, fixed moment cases. If there's beam subjected to a point load, what will be the fixed end moments and fixed end moments? I shown it here. Okay, I shown it here. So use this standard conditions and to find out the fixed end moment for the given problems. Okay, now let us consider this. Now find out what is the fixed end moments for the respective. First step is to FEM, fixed end moments for the respective spans. Now let us find out what is MAB. MAB equals to MF of AB. MF of AB equals to minus WL W. It is what? So it is exactly at the center. It is exactly at the center. So it is what? Minus WL by 8. Minus WL by 8. Minus WL by 8. So minus W. What is the minus WL by 8? Minus of W is 50. L is 4 divided by 8. So it is how much? 25 kilonewton. Minus 25 kilonewton meters. This is MF of AB. Similarly, calculate what is MF of BA. MF of BA equals to plus WL by 8. Plus WL by 8. Minus 50 into 4 divided by 8. This is 25 kilonewton meter. Similarly, calculate MF of BC. MF of BC equals to minus WL square by 12. Minus WL square by 12. Minus 15. L is 5 square divided by 12. That equals to, we'll get minus 31.25. Minus 31.25 kilonewton meters. Similarly, you calculate MF of CB. MF of CB equals to plus WL square by 12. Plus WL square by 12. So it is, so plus 15 into 2 square divided by 12. This is plus 31.25. 31.25 kilonewton meters. 31.25 kilonewton meters. Okay. So MF of CD. MF of CD equals to minus WAB square by L square. So minus W is 80, A is 2, B is 3 square divided by 80. So you will get my MF of CD is minus 57.6 kilonewton meter. Similarly, MF of DC equals to plus W A square B by L square. Plus W A square B by L square. this thing you will get. So you will get what is that? Plus 80 2 square 3 divided by L square. So this is L square. So this is 5 square, guys, please. This is 5 square. So we will get 38.4 kilonewton meter you will get. This is plus 38.4 kilonewton meter you will get. Okay. Now, next step, as I said earlier, your next step is to find out what is the distribution factors. So first step is I calculated what is the fixed end moment for the respective beams. Our next step is to find out or calculate what are all the. So next step is to calculate what are all the distribution factors. Now let us consider this. I given the table. Sorry. Sorry. So now I given the table here. Let us consider this table. Consider this table. So now let us identify the which one is the intermediate support. Now better you take this once again, guys. Let us consider this figure. So better I will put it here so that clearly I can write what are the fixed end. Sorry, what are the distribution factors. Now once again. So okay. So now let us identify this. Which one is the intermediate point now? Intermediate support now. Let us identify which one is the intermediate support. Which one is the intermediate support here, guys? Please. Here B is my intermediate support. B is my intermediate support. B is my intermediate support and C are the intermediate supports. Now B is my intermediate support and C is my intermediate support. So two supports, B and C. B and C are the intermediate. Then what are all the connected members to these intermediate supports? What is that? This will be BA and this is BC and this is CB and this is CD. Okay, those are the connecting members. Then what is the relative stiffness K for BA? So as I said earlier, guys, so B and C are the intermediate supports. If far end is fixed or continuous, then relative stiffness should be I by L. So this here the relative stiffness for BA is I by L because A is fixed support. So this is I by L. Here they are taken as E by I equals to constant. I is remains same. Cross section is same throughout the span. Then I can write this is 1 by 4. So it is I by 4. Sorry, I by 4. It is 0.25 I. Okay. Now let us come for the BC. BC is continuous. So this is also I can take I by L. I by 5. So the relative stiffness is 0.2 I. Then with respect to, now let us come for the giant C now. With respect to C, B is continuous. So this is also I by L. Means I by 5. So it is 0.2 I. Then with respect to C, D is fixed support. Then this will be, this also I by L. So this is I by 5. This is 0.2 I into I. Then what is summation of K? Summation of K is 0.25 I plus 0.2 I. This is 0.45 I. This is 0.2 I plus 0.45 I. This will be 0.45 I. So this is 0.2 I. 0.45 I. Sorry guys, please. This is also 0.2 This is also 0.2, right? This is also 0.2. So this is 0.4. This is 0.4i. Okay, 0.4i. Now let us calculate. Now let us calculate what are the distribution factors. What are the distribution factors? Okay, what are the distribution factors? So here it will be, first one is, it will be 0.56. 0.56. How I got 0.56? This is what, 0.25i divided by 0.45i. So we got 0.56. Similarly, BC you got 0.44. How it is? 0.2i divided by 0.45i. So we got 0.44. So this one you will get 0.2i divided by 0.4i will get 0.5i. This is also same, 0.2i divided by 0.4i. This is 0.5. 0.5, sorry guys, not i. So I'm just writing this 0.4. So this it is. Okay, means I will get 0.56, 0.44, 0.5 and 0.5. So this is the relative stiffness. This is the relative stiffness for distribution factors for the distribution factor are the intermediate giants. So how we calculate? K by summation of k. Summation of k we calculated. I calculated the distribution factors for the respective supports. Okay. Now let us consider this. Let us consider this joint. Let us consider the this. So we can add it here another one. So yeah, let us consider. So is enough, I think so. Let us consider this. Now consider the joints. Now what are all the members, respective members? Let us write down this. What are the respective members here? This is AB. And for B, this is BA, and this is BC, and for C, this is C. The guys, please. This is C. I can write here, and this is D. D means this is here. Okay, this here, and B. This is B, and this is A. Okay, this is so this is CB, and this is CD, CD. And this is D sheet. These are the members. Okay. Then what are the distribution factors? The distribution factor is, this is distribution factor are distribution factors. So this is 0.56. 0.56. This is 0.44. 0.56 and 0.44. And this is 0.5. And this is also 0.5. Okay. 0.5. Then what is the fixed end moments? FEMs. What is the FEMs? And FEMs. So we already calculated. Write down the FEMs. MF of AB equals to how much? Minus 25. MF of AB is minus 25. MF of AB equals to minus 25. This is plus 25. Minus 31.25. Minus 31.25 plus 31.25 minus 57.6 plus 38.4. 38.4. Okay. FEMs. These are all the FEMs. Now our first step is to now our first step is to calculate. First step is to calculate. Our first step is to calculate what are all the. First step is to calculate. So if you want, you can add one more row here so that you can clearly understood here. Guys, please, you can clearly, you can add another. So insert below. Yeah, you can add one more columns. So you can add one more columns here. Yeah. So this is the case. Sorry. So here so this is some this thing. Sorry guys, yeah, so it is not properly sitting, that's why I written that. Okay, fine. This is the case FEMs. Now our next step is to our next step is to carry out the balance. We need to do the balance now. Let us do the balance now first. Let us do the balance first. So sorry guys, sorry for this thing. Yeah. Now let us do the balance. First step is to do the balance now. Now balance. Let us do the balance. Let us do the balance. How to do the balance? So while explaining, I said you how to do the balance. Summation of the FEMs. In the previous problem, while explaining, I said you how I have to do the balance. Sorry. Summation of the FEMs at the intermediate joints and multiply with the distribution factors. Change the sign. Write down the values. Now. So what is the summation of intermediate joints? It will be plus 25 minus 31.25. So it is minus 6.25. Minus 6.25 multiply with the 0.6. Change the sign. Write down the values. Very simple. So this is plus 0.35. You will get plus 0.35. Plus 0.35. So then similarly you will get this one plus 2.75 will get, and similarly we will get at this point. Now what summation of FEM? Summation of FEM is what? At this point, at the point C, I have 31.25 minus 57.6 minus 57.6 26.35 multiply with the minus 20.65 minus 26.35 multiply with the 0.5. Change the sign, write down the values. So how much you will get? Minus 26.35 multiply with the 0.5 multiply with the 0.5, you will get how much you will get? You will get 13.175 plus 13.175. This also plus 13.175. Next step is to do the carryover. How to do the carryover? I explained to you people, guys, in the previous example. We need to do the carryover for the support, which adjacent support, which is fixed. It is fixed or continuous. So let us say my joint A is fixed. I can do the carryover. Here also joint with respect to joint B, C is continuous. I can do the carryover. Here also I can do the carryover. Here I can also do the carryover because with respect to C, D is fixed. So D is fixed. Now let us see this one. Let us see. Now with respect to B, A is fixed. I have to do the carryover. How much? 50% of the moment should be to carry over the adjacent support. So this is how much I need to do the carryover. So how much it is? 1.75. And this one 6.5 6.587, and this one you will get 1.375, 1.375, and this 13.175 will half of this would be 6.587, 6.58. So this is 6.587. This is 13.15, 13.175, guys, please. This is 13.175. 13.175. Okay. Now I did the carryover. Next, once again, I need to do the balance. Now 6.58 multiply with the 0.56, change the sign, write down the values. Very simple. So now it is minus 3.688. Minus you will get 3.688 you will get. Similarly here minus 2.89, minus 0.687, minus 0.687. This is minus 687, 0.687 you will get. Now once again do the carryover. Now I did the balance. What are the movement is there? Multiply with the distribution factor items, carry over. Half of the movement should be carried here, half of the movement should be carried here, half of the movement should be carried here, and half of the movement should be carried here. So why? Because with respect to B, A is fixed. With respect to B, C is continuous. With respect to C, B is continuous, D is fixed. So there half of the movement should be transferred. So this is minus 1.84, minus 1.84 here, and here minus 0.343, and here minus 1.445, and here minus 0.343, minus 0.343. Now once again do the balance. Here you will get plus 0.192 plus 0.150, here plus 0.722 plus 0.722. Guys, please, I already explained how to do the balance. Summation of the movements. Here minus summation means 0 plus minus 0.343, multiply with the distribution factor, change the sign, write down the values. So same thing I did it here. And carry over. Let us do the carry over. Half of the movement here, half of the movement here, half of the movement here. Then half of the movement will be carried there. Okay. Movement will be carried there. Now, so this will be 0.096. Then here, so this is 0.075, and this will be 0.361, and this will be 0.361. Now once again do the balance. So if you do the balance, this is minus 0.202, minus 158, and this is minus 0.30375, and this is minus 0.0375. And now once again do the carryover. Here, carry over here. Now carry over, do the carryovers. So this will be minus 0.10, and this will be minus 0.079, and this will be minus 0.018, and this will be the minus 0.018, minus 1.0. Now let us do the once again balance. Let us do the once again the balance. So if you do the balance, it will be 0.01 and it will be plus 0.008, and this will be plus 0.04 and this will be plus 0.04. So you stop here. I can do once again the balance and carry over. So let us if you want we can do it here. I will stop here. So we can stop here and write down the final movements. So we can stop and we can write down the final movements here. Okay. So so if you are writing final movements, so we need to do the summation of all the values. Let us do from FEM do the summation of all values. FEM do the summation of all values. Then if you are writing final, so if you are writing final, do the summation of all the values. So I'm just taking up, and let us do the, if you are writing summation of all the values here, final movements. Or guys, I don't have any space here. Better we'll go to the next slide. So if you are writing final movements, adding all those values, you will get the final movements. What is that? M AB equals to, will get MAB equals to minus 25 kilonewton movement. Roughly we'll get minus 25 kilonewton meters. MBA equals, nearby value has to get 24.8 kilonewton meters. Similarly, MBC equals to minus 24.8 kilonewton meter, and MCB equals to 44.39 kilonewton meters, and MCD equals to minus 44.38 kilonewton meters, and MDC will get 45 you will get. Okay, 45 kilonewton meters you will get. Okay, so by using that I got these values, MAB, MBA, and this thing. Okay, now so these are final movements. So final movements, so let us write down better. These are the final movements. So now we have the real beam diagram. So let us take once again consider this real beam diagrams, and I will put it here. So sorry. So I will just paste here. Yeah. Now let us consider this. So if you consider this, so are better. So you know that what is the final moments? You know what is the final moments? I already written that. I hope I'll just note it down here. So what all the moments we got? Okay, what all the moments I got? I will just note it down here. So here we got 25, and this one you will got 24.8. This is also 24.8 kilonewton meters, and this is also 24.8, and this you got 44.39 kilonewton meters, and this one you got 45. This one you got 45 kilonewton meters. Okay, these are final moments you got. Now I have reactions. Let us find out the reaction first. Next, to draw the SFD VMD, find out the reaction at the respective this thing. This is RA, and this is RB, and this is RC, and this is RD. How to find out this? So once again you write down separately. Let us take down this once again separately. Let's separate beams diagram. You can draw. This is AB. This is for BC. And this is for CD. Okay, this is for CD. Now, CD. Now, you show those movements here. Show those movements along with the loads. 2 meter, and this is 2 meter, and this is 15 kilonewton per meter. And what are the support moment you got? This is B and this is C. This is C and this is D. This is A and this is B. Okay, shown here. This is RA, RB dash, RB double dash, RC dash, RC double dash, and this is RD. Okay, this is RD. Now here, what is the moment? I already calculated. This is 45 and this is 44.39. And one unit load 80 kilonewton. This is 2 meter and this is 3 meters. This is 2 meter and this is 3 meters. Now let us calculate. Let us calculate. Now let us calculate the support reactions. Let us calculate the support reactions. First, here let us take sigma MB that equals to 0. Let us take sigma MB that equals to 0. You take sigma MB equals to 0. Then this will be RA into 4. With respect to this rotating clockwise, this is plus. The next minus 50 into 2. So please let us write down the values here. How much we got? 25, and this is 24.8. This is 24.8, and this is 44.39. Okay. The next 50 into 2. Then with respect to B is rotating anti-clockwise, minus 25. With respect to this is rotating clockwise, this 24.8. That equals to 0. Then RA equals to 25.05. So that, okay. Then sigma Fi that equals to 0. Then what is that? Sigma Fi that equals to 0. Sigma Fi that equals to 0. Then RA is acting upward. RA is acting upward. RB dash is acting upward. 55 kilonewton is acting downward. That equals to 0. Then RA I got. Then let us find out what is RB dash. So RB dash equals to 50 minus of 25.05. Then RB equals to, we'll get RB dash, sorry, RB dash equals to how much? RB dash equals to 24.95. 24.95 kilonewtons. Okay. Similarly, let us take this beam. Let us take this beam. Sigma MB that equals to 0. RC dash into, this is 5 meter. RC dash into 5 is minus anti-clockwise, plus 15 into 5 into 2.5. Load is no distance into distance by 2. Then next minus 24.8 plus 44.39 that equals to 0. Then RC dash equals to 41.42 kilonewton you will get. Similarly, sigma Fi that equals to 0. Let us take sigma Fi that equals to 0. Sigma Fi that equals to 0. RB double dash acting upward plus and RC dash acting upward plus that equals to 15 into 5. Then I can easily find out what is RB double dash. RB double dash is to get 33.6. Okay, 33.6. Now let us see this one. Now next, sigma MC that equals to 0. Sigma MC that equals to 0. RD into 5 minus plus 80 into 2. 80 into 2 plus 80 into 2 plus 80 into 2 minus 44.39 plus 45 that equals to 0. Then RD will be then what is RD? Once again guys, please, RD you calculate RD will get 32.12. 32.12. Then sigma Fi equals to 0. RC double dash plus RD that equals to 80. Then RC double dash equals to 47.87 kilonewton you will get. 47.87 kilonewton you will get. Okay, so you will get this much, 47.87 kilonewton. Now we got this. Now we got this. Now let us draw. How to draw? How to draw? How to draw? So how to draw? How to draw shear force diagram? How to draw shear force diagram? So here, how to draw shear force diagram? I'll show you how to draw shear force diagram. Let us draw shear force diagram. How we need to draw shear force diagram? I'll show you how to draw shear force diagram for the given beam. Okay. Sorry. Here. So here, what is that? Now here we got the reaction. RA value I know. RA value I know it is 25.05. And RB I calculated. RB is of RB dash and RB double dash. You calculate, you will get this is 58.55. 58.55 kilonewtons. Similarly, RC you calculate you will get 89.20 kilonewtons. And you calculate RD calculated, you will get 32.12. 32.12 you will get. Okay. Now this is a zero datum line. Now let us start with this. Let us start drawing. Let us start drawing SFD. 25.05. This is 25.05. It is to here to here there is no load. Here to here there is no load. So then plus 25.05 minus 50, you will get 24.95. 24.95 minus 24.95. It's somewhere here. Here to here there is no load. 24.95 minus 24.95 plus 58.55, 33.66 you will get. Let us say this will come somewhere here. 33.66. So this is this is 33.66. Here to your UDL where this inclined plus 33.6 minus 15 into 5. So you'll get 41.42. 41.42 kilonewton minus 41.42 plus 89, you will get 47.87. So let us say 47.87, it will come somewhere here. Okay, just jam the line. Here to here there is no load region. Plus 47.87, sorry, plus 47.87 minus 80 plus minus 31.12. So we'll get minus 31.12 here. Minus 31.12. Here to here there is no load region. This is what? 31. So this is, sorry guys. So 31.12 plus 31.2 minus 31.2, it will be 0. So this is 0 datum line. Like this, you started with the 0, we have to end with the zeros. This is kilonewtons. So this is kilonewtons and this is kilonewton. Okay, this is plus and this is minus, plus and this is minus, this is plus and this is minus. This is how we have to draw SFD for the given beam. This is given beam. Okay, this is how we need to draw the SFD. Similarly, you can draw for the BMD also. Let us draw the datum line. Let us draw the datum line. Here you can see first you draw bending moment due to loading. Let's draw bending moment due to loading. So this is point load. This is point load. And this is UDL. This is UDL. Variation is UDL. And this is triangular variation, like this. So what is this? This is WL by 4. WL by 4 you have. This is WL by 4. WL by 4 means W is how much? 50. L is 4. So it is 50 kilonewton meters. And this is WL square by 8. What is W? W is 15. 5 square divided by 8. We'll get how much? You will get 46.9. You will get 46.9. 46.9 kilonewton meters. So if you want, you can erase, don't get confusions. This is 41 point, sorry, not able to erase that. So I can erase this one, I think so. Yeah, so WL square by 8, sorry, that also. I erased that also. So this was this is WL square by 8. You will get how much? 46.9 you will get 46.9 kilonewton meters you will get. And this one you will get W square by 8. This is 96 you will get. So 96 you will get 96 at this portion, 96 kilonewton meters. Okay, 96 kilonewton meters. So how I got this? This value will be WAV by L. W is 80. W is 80. A is 2 meter and B is 3 meter. Okay, A is 2 meter and B is 3 meter. Now, next step is to draw the support moments. Then next, support moment, already you know what is MA, 25 here. Let us mark that 25. This one is 24 and this one is 44 and this one is 45. Okay, this one is 45, this one is 44. Now just join those lines. Okay, this is minus, this is minus and this minus, this is plus reason, this is plus reason and this is plus. Okay, and this is how much? This is 25 kilonewton meters and this is 24.8 kilonewton meters and this is 44.39 and this will be 45. You will get 45 kilonewton meters. Okay guys, this is how we need to draw the BMD. This is BMD, bending moment diagram, and this is SFD. Okay, safe force diagram. So I clearly show here. Clear representations is done here. You can see, and this is the clear representation of the BMD, and here everything BMD and SFD. Okay, and here all units of SFD is kilonewton. Unit of SFD is kilonewtons. So dimensions are in kilonewtons. Here BMD dimensions are in kilonewton meters. So here BMD dimensions in kilonewton meters. So guys, please, as said earlier, what is your steps? So please, whatever the given problem is there, your first step is to find out the fixed end moment. So for the given problems, first you find out what is the fixed end moment. So find out what is the fixed end moment for the respective support moments, like MF of AB. So if you take AB as a span, MF of AB, MF of BL, like this, we need to find out for the each span. Next, find out distribution factors by selecting the relative stiffness of the each joint and members right on the relative stiffness. Then next, you need to draw the what is that? Moment distribution table. We need to consider moment distribution table, and we need to find out what are all the final moments. So I got final moments here. Then calculate what are all the support reactions to draw SFD. Then draw the BMD. So this is the SFD given, this is the SFD given, and this is the BMD. Okay, this is BMD, and this is the BMD. So we need to find out what are all the support movements, and first while trying BMD, First draw due to the bending moment due to loading. First you draw, then what all the support moment you calculated, then you show it here. Okay, show it here. So this is how we need to do moment distribution method, analysis of continuous beams, or analysis of continuous beam by using moment distribution method. I hope you understood by using these two examples. I hope you understood how to do moment distribution method, or how to analyze continuous beam by using moment distribution method. I hope you understood, guys. Thank you.